The rating on a light fixture, such as 60 watts max, refers to the maximum heat that the fixture is designed to safely dissipate, not the current draw of the lamp. Incandescent lamps generate a substantial amount of heat as a byproduct of producing light. This heat can damage the fixture, its wiring, or surrounding materials if it exceeds the fixture's design capacity. Fluorescent lamps, including compact fluorescent lamps or CFL and light-emitting diode or LED lamps, operate much more efficiently than incandescent lamps. They produce significantly less heat for the same amount of light output. Because of the slower heat production, a fluorescent or LED lamp with a wattage lower than the fixture's maximum rating can be safely used, even if its light output is equivalent to a higher wattage incandescent lamp. For example, you can safely use a 13-watt fluorescent lamp in a fixture rated for 60 watts incandescent because the 13-watt fluorescent lamp will produce far less heat than a 60-watt incandescent lamp. It is important to understand the relationship between wattage, light output, and heat generation to make informed decisions about lamp selection. Wattage is a measure of power consumption, or the rate at which the lamp uses energy. Light output is measured in lumens, which indicates the brightness of the lamp. Heat generation is a consequence of inefficiency in the lamp's design. Incandescent lamps are particularly inefficient, converting only a small percentage of the electrical energy they consume into light, with the remainder being converted into heat. Fluorescent and LED lamps are much more efficient, converting a larger percentage of electrical energy into light and producing less heat. When selecting a replacement lamp for a fixture, it is crucial to consider both the wattage rating of the fixture and the desired light output. Choose a lamp with a wattage that is equal to or less than the fixture's maximum rating and with a lumen output that provides the desired level of brightness. A direct conversion from incandescent wattage to fluorescent or LED wattage is not precise because of the different efficiency levels. However, there are general guidelines that can be used to estimate the equivalent wattage. For example, a 13-watt fluorescent lamp typically produces about the same amount of light as a 60-watt incandescent lamp. Similarly, a 9-watt LED lamp may produce the same light as a 60-watt incandescent lamp. These are just approximate equivalents, and the actual light output can vary depending on the specific lamp model. To determine the appropriate wattage for a fluorescent or LED lamp, it is best to compare the lumen output of the lamp to the lumen output of the incandescent lamp it is replacing. Look for the lumen rating on the lamp packaging, and choose a lamp with a similar lumen output to the incandescent lamp you are replacing. In summary, the 60 watts max rating on a light fixture indicates the maximum heat that the fixture can safely dissipate. Fluorescent and LED lamps produce less heat than incandescent lamps, so a lower wattage fluorescent or LED lamp can be safely used in a fixture rated for a high wattage incandescent lamp, provided that the lumen output is sufficient to provide the desired level of brightness. Always ensure that the replacement lamp's wattage is equal to or less than the fixture's maximum rating to prevent overheating and potential damage. Safety is paramount when dealing with electrical fixtures and lamps. It is good practice to turn off the part of the fixture at the circuit breaker before replacing a lamp. Also, be sure to follow any specific instructions or warnings provided by the manufacturer of the fixture or lamp. If you are unsure about any aspect of lamp replacement or electrical safety, consult a qualified electrician. Understanding the principles of wattage, light output, and heat generation will help you make informed decisions about lamp selection and ensure the safe and efficient operation of your lighting fixtures. This understanding is particularly important when upgrading to more energy-efficient lighting technologies such as fluorescent and LED lamps. By choosing the right lamps for your fixtures, you can save energy, reduce your electricity bill, and improve the quality of light in your home or workplace. When considering energy-saving lamps, you're essentially dealing with a trade-off between power consumption and light output, along with heat generation. Traditional incandescent bulbs produce light by heating a filament until it glows. This process is inherently inefficient, with most of the energy being converted into heat rather than light. Fluorescent lamps, on the other hand, use a different mechanism to produce light. They pass an electric current through a gas containing mercury vapor, which causes the gas to emit ultraviolet or UV light. This UV light then strikes a coating of phosphor on the inside of the lamp, which converts the UV light into visible light. This process is much more efficient than heating a filament, so fluorescent lamps produce more light for the same amount of power consumption, and they also generate less heat. LED lamps are even more efficient than fluorescent lamps. They use a semiconductor device to emit light when an electric current passes through it. LED are extremely efficient at converting electrical energy into light, and they produce very little heat. This makes them the most energy-efficient lighting technology currently available. When selecting an energy-saving lamp, it's important to consider the color temperature of the light it produces. Color temperature is measured in Kelvin or K, and it describes the warmth or coolness of the light. Lower color temperatures, such as 2700 Kelvin, produce a warm, yellowish light that is similar to incandescent light. Higher color temperatures, such as 5000 Kelvin, produce a cool, bluish light that is similar to daylight. The appropriate color temperature for a particular application depends on personal preference and the desired ambient. For example, warm light is often preferred in living rooms and bedrooms, while cool light is often preferred in kitchens and offices. Another important consideration is the lamp's color rendering index, or CRI. The CRI measures how accurately a lamp renders the colors of objects compared to a natural light source. A higher CRI indicates more accurate color rendering. For applications where accurate color rendering is important, such as art studios or retail displays, it's best to choose a lamp with a high CRI. In general, LED lamps have higher CRI values than fluorescent lamps. Finally, it's important to consider the lamp's lifespan. Incandescent lamps have a relatively short lifespan, typically around 1000 hours. Fluorescent lamps have a longer lifespan, typically around 10,000 hours. LED lamps have the longest lifespan, typically around 25,000 hours or more. Choosing a lamp with a longer lifespan can save you money in the long run by reducing the frequency of replacements. In conclusion, when choosing an energy-saving lamp, consider the wattage, light output, heat generation, color temperature, CRI, and lifespan. By carefully considering these factors, you can select a lamp that meets your needs and provides the desired level of illumination while saving energy and reducing your electricity bill. Remember that the wattage rating on the fixture dictates the maximum amount of heat it can handle safely. Always choose a replacement lamp with a wattage that is equal to or less than the fixture's maximum rating. Moreover, be aware of the specific electrical codes and regulations in your area. These codes provide guidelines for safe electrical practices, including the installation and use of lighting fixtures and lamps. Familiarize yourself with these codes and follow them carefully to ensure the safety of yourself and others. If you have any questions or concerns about electrical safety, consult a qualified electrician. Electricity can be dangerous if not handled properly, so it's always best to err on the side of caution. One important safety aspect is understanding the wiring in your home. Most homes have a 120/240 volt electrical system. The 120 volt circuits are used for lighting, small appliances, and other general purpose loads. The 240 volt circuits are used for larger appliances, such as electric stoves, clothes dryers, and air conditioners. It's important to know which circuits are which, and to avoid overloading any one circuit. Overloading a circuit can cause the circuit breaker to trip, or it can even cause a fire. To determine the amperage of a circuit, look at the circuit breaker. The amperage rating is typically printed on the breaker. For example, a 15 amp breaker can handle a maximum of 1800 watts at 120 volts or 3600 watts at 240 volts. It's important to stay within these limits to avoid overloading the circuit. When plugging in appliances, be sure to use the correct type of outlet. 120 volt appliances should be plugged into 120 volt outlets, and 240 volt appliances should be plugged into 240 volt outlets. Never try to plug a 240 volt appliance into a 120 volt outlet, or vice versa. This can damage the appliance and potentially cause a fire. Another important safety aspect is ground fault circuit interrupters, or GFCIs. GFCIs are special outlets that are designed to protect you from electric shock. They are typically found in bathrooms, kitchens, and other areas where there is a risk of water contact. GFCIs constantly monitor the current flowing through the circuit, and if they detect a leakage of current, they will quickly trip the circuit and cut off the power. This can prevent a potentially fatal electric shock. It's important to test GFCIs regularly to make sure they are working properly. To test a GFCI, simply press the test button on the outlet. The outlet should trip and cut off the power. Then press the reset button to restore the power. If the GFCI does not trip when you press the test button, it needs to be replaced. One final note on electrical safety: be sure to inspect electrical cords and plugs regularly for damage. If you find any damaged cords or plugs, replace them immediately. Do not try to repair damaged cords or plugs yourself. Also, never run electrical cords under rugs or furniture, as this can create a fire hazard. By following these simple safety tips, you can help to prevent electrical accidents and keep yourself and your family safe. Electricity is a powerful and useful tool, but it must be treated with respect. With a little knowledge and caution, you can enjoy the benefits of electricity without putting yourself at risk. Remember the principles of electrical safety. Firstly, always turn off the power at the circuit breaker before working on any electrical fixture or appliance. Secondly, never overload a circuit. Thirdly, use the correct type of outlet for each appliance. Fourthly, test GFCIs regularly. Fifthly, inspect electrical cords and plugs regularly for damage. By adhering to these 5 principles, you can significantly reduce the risk of electrical accidents and ensure the safe operation of your electrical system.